Hi everyone, and welcome to your next instalment of the summer introductory work which you are completing for one of our psychology courses at New College. So the area of focus in my video for this particular section, my name's Fiona by the way, is biopsychology with a specific focus on what we call neuroanatomy, which is the study of the brain. So we're going to do a little bit of background work in terms of the brain. I hope you're looking forward to studying the brain. It's one of the most fascinating parts of our course, I would say, looking at all the intricate details of how your brain works and all the different parts. So we're going to do that first, and then we're going to move into some work on what we call the key studies in psychology. And the one that you're about to find out about is probably one of the most famous pieces of research that we have in biopsychology, looking at the curious case of a man called Phineas Gage, which was first reported in 1868, so a long time ago now, but you can see how important it is that we're still looking at this study from 1868. Okay, so that's the plan for this particular short section, all about biopsychology. So let's get going. So when we're talking about neuroanatomy and the study of the brain, one of the most widely accepted theories that we have in neuroanatomy is known as localization of function. So you can see on the right hand side that I've given you a very brief definition of this concept, and it is, in a nutshell, that specific functions are located in specific areas. So in human behavior and in animal behavior, certain things that we do, so certain actions and behaviors and responses, are located in a specific region of what we call the cortex, which is the outer layer of the brain, which you can see on the left hand side. So your brain is divided into lots of different cortexes and lobes and regions, and the theory is here that specific functions, for example in humans, language and memory, are located in a very specific part. Now this is helpful to us because we know that if someone suffers damage to a specific region of the brain, then physicians and doctors can make predictions as to what the symptoms of damage will be, okay, how they're going to need help rehabilitating and so on and so forth. So really core idea in neuroanatomy. So what we're going to ask you to do here is watch a really short but quite intense video clip outlining what some of the core regions of the brain are, which you will study when you get onto your courses at New College. The video lasts about 6 minutes. You can stop and start the video clip as much as you want if you're wanting to take notes, but at the end of the 6 minutes there's going to be 10 key questions which you will be expected to answer and then bring with you, obviously, after the summer when you start your lessons. So you can play it backwards and forwards as much as you want. There is quite a lot of lingo, quite a lot of terminology, so we want to be paying attention here. Okay, so let's get cracking. This is our key video that we're going to watch to do some background on localization of function.
Looking at the lumpy 1.3 kilogram pink organ, the consistency of porridge, that is your brain, you may wonder, how does this organ allow me to move my body, understand and construct language, remember the past and plan for the future, as well as having a conscious understanding of the world around me? Is it all just randomly connected up, or are there particular areas for each individual functional task that I can perform? In this episode of Psych Boost, localization of function in the brain. Localization of function is the idea that the production of behavioral functions like moving your arm or producing speech are localized to particular regions of the brain. This is in contrast to a holistic understanding of the brain, in which functions are spread out across large areas or the entire brain. In this video, we're going to explore 6 regions of the brain. These demonstrate localization of function. They are the visual cortex, the motor and somatosensory cortices, the auditory cortex, and Broca and Wernicke's areas. The first 4 are found in both sides of the brain. However, Broca and Wernicke's areas, which deal with producing and understanding language, are generally in the left hemisphere. This is an example of hemispheric lateralization. Hemispheric lateralization is the left and right hemispheres of the brain have some cognitive functions that are specialized to that side. Broca and Wernicke's areas are the best example of hemispheric lateralization of the left hemisphere, with the right hemisphere being dominant in visuospatial functions. A great evaluation showing hemispheric lateralization is Sperry's split brain patients, covered in another video. The visual, motor, and somatosensory cortices are contralateral, meaning that the right hemisphere moves and senses the left side of the body, as well as dealing with visual information from the left visual field of both eyes. And of course, meaning the left hemisphere moves and senses the right side of the body, as well as dealing with the visual information from the right visual field of both eyes. I'm going to be using the word cortex a lot. It means the thin outside layer of the brain. It's a mass of cell bodies, and it's where much of the brain's processing takes place. It's often termed grey matter because it's mostly cell bodies, and its axons are unmyelinated. The cortex is between 2 and 4 millimeters thick in humans and distinctively folded to give it a greater surface area. White matter, on the other hand, is mostly myelinated axons with few cell bodies, giving it a white appearance. Firstly, the visual cortex. The occipital lobe is the smallest of the 4 lobes of the brain, alongside the temporal, frontal, and parietal. The occipital lobe is found at the back of the brain. The occipital lobe is known as the visual processing center containing the visual cortex. Damage to the visual cortex, as you might imagine, can cause partial or complete blindness, known as cortical blindness. As the left and right visual cortices are contralateral, damage to one will result in sight loss in the opposite visual field. The motor and somatosensory cortex. These structures run alongside a fold in the brain called the central sulcus. That separates the frontal lobe from the parietal lobe. The motor cortex is found in the frontal lobe and the somatosensory in the parietal. The motor cortex in each hemisphere plans and carries out voluntary motor movements on the opposite side of the body. Damage to one side of the motor cortex can lead to loss of fine muscle function or even paralysis on the opposite side of the body. Somatosensory cortex. The somatosensory cortex in each hemisphere detects sensations from the opposite side of the body. Damage to one side of the somatosensory cortex can lead to the loss of sensation from the opposite side of the body. Somatosensory damage can lead to ignoring areas of the body, known as neglect syndrome, or losing the ability to recognize objects by feeling them, known as agnosia. The auditory cortex. The auditory cortex is located at the top of the temporal lobe on both sides of the brain and receives auditory or sound sensations from the ears. Damage to the auditory cortex can lead to deafness. Closely associated to the auditory cortex in the left hemisphere is Broca's area. Discovered by Paul Broca after the case study of a patient named Louis Lebrogne, nicknamed Tan. Tan, despite clearly understanding what was said to him, could only produce the word tan. The post-mortem of Tan's brain showed extensive damage to an area of the brain at the bottom of the left frontal lobe. Along with similar cases and dissections, Broca suggested Broca's area was responsible for speech production. Damage to Broca's area leads to Broca's aphasia, also known as expressive or motor aphasia, difficulty in producing fluent speech. The speech produced is slow and short, requiring significant effort, and is missing words needed for correct grammar. Wernicke's area is also associated with the auditory cortex in the left hemisphere. It's located in the temporal lobe, just next to the auditory cortex. Carl Wernicke found that some patients could produce quick, fluent-sounding speech, but not understand speech. The fluent speech they produced, however, was often strange, making no sense. When these patients had postmortems on their brain, damage was found at what's now called Wernicke's area, the area of the brain used to interpret speech. Damage to Wernicke's area leads to Wernicke's aphasia, also known as receptive or sensory aphasia, a difficulty in understanding written or spoken language and producing speech that, while sounding fluent, lacks meaning. Damage to both Broca and Wernicke's area can lead to a global aphasia, the inability to produce or understand speech.
Okay, so That's the end of the introductory video on the areas of the brain, okay, known as localization of function. As I mentioned previously, you can watch this video clip now back to yourself if you need to kind of like tighten up on some of those ideas. But what we would like you to do at this stage, okay, is try and answer the 10 key questions. So I'm going to ask you to kind of pause these questions here on the screen and rewatch it as much as what you need to in order to be able to answer these questions in some good detail. Okay, remember your teachers will be checking these when you come back after the summer. Okay, so pause this here, and then we're going to move away from localization of function and into our key study. Okay. So, for all areas of psychology, we need to basically look to key pieces of research to support the notions that we've been describing. So in the case of localization of function, one of the best studies to demonstrate that certain areas of the brain are possibly responsible for certain functions is the curious case of Phineas Gage. So you might want to watch the video and take notes. There will be again some questions at the end of this short video clip for you to tackle. This video is not as intense, there's not as much kind of key terminology. It's just a really interesting case, all right, for you to get to grips with. So watch the video carefully and then try and answer the questions which follow.
Most of the time, when a large object passes through your skull, you will receive what is called a lethal injury. But for one person named Phineas Gage, that famously did not happen. And you don't survive an iron rod through your brain without psychologists paying attention, so his name can be found in basically every intro to psych class. But if your story travels far and wide, chances are it doesn't get told right every time. So it's no surprise that the tale of Phineas Gage has become quite colorful and inaccurate in most cases. But what's true is that he survived a seemingly unsurvivable injury, and his stunning recovery helped settle some debates about how the brain works. The first part of the story is usually told correctly. In 1848, Gage was 25 and a foreman helping lay railroad tracks in Vermont. He was using an iron rod 3.5 feet long and over an inch wide to pack sand onto an explosive when it went off, firing the rod at his head. The rod entered his skull below his left eye and then came out through the top of his head, landing about 30 yards behind him. He miraculously survived, but the doctor who first treated him reported that his friends said he was, quote, no longer Gage. The injury had changed his personality. And that's about where the story starts to spiral out of control. In some stories, Gage is described as becoming a monster of a man, a mean psychopath that could never function again in society. Some textbooks say that he never worked again, that he became a vagrant or a circus attraction, or in one example, that he survived for 20 years with the rod still in his skull, but pretty much none of that's true. We only have a few primary sources for Gage's life, and most are from the doctor who first treated him, an American physician named John Harlow. But those records suggest that in some ways, Gage recovered pretty quickly. Within 4 weeks of the accident, Harlow recorded that Gage's memory was as perfect as ever, for example. A visiting doctor wrote that a stranger would notice nothing peculiar about him. And 6 months later, Harlow wrote that Gage was fully recovered, though that might have been a little optimistic. He later described Gage as being intellectually impaired, nothing extreme, just a little slower at things. Like Gage had previously been thought of as one of the best at his job and a shrewd, smart businessman, but some of his post-injury records suggest he became kind of average. And it is true that he didn't get his old job back, though that probably wasn't due to a cognitive impairment, but rather because he became harder to work with. Reports suggest that after the accident, he lacked respect and kindness, was more profane, and gotten more conflicts. In other words, he suffered a social impairment, at least at first, but he didn't become like a wholly horrible person like some accounts suggest, and he did, in fact, hold down a steady job later on. Gage moved to Chile and and worked as a carriage driver for years. Though not considered as high status as his old job as a foreman, it still required him to exercise social skills as well as cognitive and motor skills. And a doctor who knew him there described him as having, quote, no impairment whatever. So clearly, he wasn't permanently unemployable or unable to function in society. It's likely that such larger-than-life stories of Gage arose in part through honest mistakes. Like the idea that he was a circus attraction may have arose because he likely made some paid appearances at Barnum's Museum in New York, which, though named for that same P.T. Barnum of Barnum and Bailey, was not part of any circus. And it seems like some psychologists writing about him later on got his case mixed up with later cases of brain damage. Also, before PDFs and the internet, it was likely pretty hard for textbook writers to get their hands on the actual case notes to fact-check what they'd heard. But another big reason that myths grew about Gage is the same reason he's a pretty important figure in the history of psychology. Almost immediately, he became like a pawn in fights over how the brain works. Today, we take for granted the idea that parts of the brain are specialized for certain purposes, but at the time, no one was certain of that, and others had a more holistic view, basically that all of it was equally important for pretty much everything. In fact, at the time, the biggest proponents of specialization were phrenologists, adherents of the racist pseudoscience which proposed that personality and intelligence were related to bumps in the skull. So some psychologists may have emphasized Gage's recovery specifically to attack phrenology, and being able to recover did seem to argue against specialization. After all, if the brain was specialized, you couldn't lose a lot of brain tissue and still be mostly fine. Meanwhile, according to the phrenologists, who again were wrong, the rod hit him in the parts of the brain responsible for benevolence and veneration. So they likely overemphasized the changes in his social abilities, leading to the bizarre stories that then snowballed. Today, Gage's true story fits with our understanding of brain specialization, just not the way that phrenologists thought. What exactly happened to his brain wouldn't be studied in depth until over a century and a half after his accident. Gage died 11 years after the incident and was buried, but his skull was later exhumed. And in a study published in 2012 in PLOS ONE, researchers were able to create a 3D model of that skull to fully examine what happened to it. Based on the placement of the fractures and what's known from modern imaging of brain anatomy, the researchers suggested that the damage was largely to his left frontal lobe, a part of the brain which is associated with decision-making and emotional processing. That might explain some of the more subtle deficits he suffered. They also found that it was likely most of the damage occurred to white brain matter instead of gray matter. Brain tissue that appears white is made of the myelinated axons that connect neurons, while gray matter is made mostly of neuron cell bodies. The research proposed that Gage lost around 11% of his white matter, specifically white matter connecting the orbital frontal cortex of the frontal lobe to the limbic system, while perhaps only losing 4% of his gray matter. And that could help explain his recovery, because while gray matter doesn't grow back well after injury, it is possible for white matter to regenerate. This also makes Gage's case look a lot like modern degenerative diseases like frontotemporal dementia. Similar brain regions are affected by the disease, and some of the symptoms associated with personality change can also occur. And that modern comparison is a good reminder of why it's important to debunk the myths about Phineas Gage. The wild stories about him becoming an unemployable vagrant can end up dehumanizing him. And we don't want to do that to people who experience accidents or brain damage today. So keeping in mind the full life he lived after his accident can help remind us that everyone deserves to have their story told right, and the human brain is incredibly resilient. Thanks for watching this episode of SciShow Psych. If you like learning about the human brain, you are in the right place. Check out some of our other episodes to learn more about how our minds work. I really like the one that we did on how surprisingly smart babies are, for example, because my baby is definitely surprisingly smart. And don't forget to click on that subscribe button to make sure you never miss an episode.
Okay, So that then is the curious case of Phineas Gage, which I think you'll agree with me is quite a baffling story of how one man survived such an extreme brain injury. But this piece of research is really important to our understanding of what it shows about the functions located in that kind of frontal lobe. Remember, as he said in the video, there are a lot of myths surrounding the case of Phineas Gage, and it's important that we get the right details down. So we now want you to answer these 10 questions, okay? So what was his occupation? How old was he when he sustained his injury? What caused his accident to occur? What were the exit and entry points of the rod in relation to Phineas's brain? What did his friends claim after the accident? What did doctors claim about 4 weeks later? What were the reasons that he did not get his old job back? Now that's really important. And then how old was he when he died? And according to reports in 2012, after his body was exhumed to allow us to analyse the brain, which lobe of his brain was damaged and what are some of the functions that we associate with that lobe? So work your way through those 10 questions, guys. And once you are done with that, then this is the short section on biopsychology and neuroanatomy completed. Well done.